Assalamu alaikum students. How are you all? Today I'm here to discuss main points of chapter number 1 of new updated book Maths updated book which we are studying in this year. Okay. So comes to our main points, and I have taken these main points from the book. Okay. All the main points are written in your book. You have to underline all that. The first one is whole numbers. Okay, I think so all of you know about whole number in the previous classes. Very good. What are the whole numbers? Whole numbers are such numbers which are not in the form of fraction or decimal. Clear? And what is the first whole number from which we have to start whole number? Yes, we have to start whole number from 0. And we have to start natural number from 1, 2, 3. Clear? Now we comes to the first point. Whole numbers. The whole numbers are the numbers without fractions. Okay. Whole numbers are such numbers which are without fraction and without decimals. Clear? Second, it is collection of positive integers and 0. As I already told you, that whole number start with 0 and all the positive number we have. So the whole, it is a collection of positive integers and 0. Third, simple represent whole number is W, capital W. Okay. For example, 0, 1, 2, 3, 4, all these are whole numbers. Number 4, whole numbers divided into 2 groups. Okay. The first one is even number and the second one is odd number. Look here. Here we have 0, 1, 2, 3, 4. Here, few numbers are divisible by 2, like 2 and 4. Both of these are divisible by 2. This means these are even number. And obviously, some are not divisible by 2, like 1 and 3. So these are odd number. Zeros, as you know, the 0 is divisible by all the numbers in this word. So obviously 0, 2, 4, 6, 8, all these are divisible by 2. Clear to all? Okay, now we can move towards the next points. Number 5, even numbers. These are whole number divisible by 2. For example, 2, 4, 6, 8, 10, 12, so on. You can continue all the number which are divisible by 2. Number 6 point, odd numbers. These are whole numbers that are not divisible by 2. For example, 1, 3, 5, 7, all these are not divisible by 2. So these are called odd numbers. Number 7, prime numbers. This one is very much important because our initial exercise is based on these prime numbers. Okay. A prime number is a whole number that has exactly 2 different factors. 1 and the number itself. So all 2, 3, 5, 7, 11, 13, all these are prime numbers. I will discuss prime number in detail in the next points. Okay. Today I will also tell you the first 100 prime numbers. Okay. 8, composite numbers. It is a whole number that has more than 2 different factors. Clear? More than 2 different factors mean at least it has 3 factor and maximum has no limit. Okay. So 4, 6, 8, 9, all are the composite numbers. Number 9, whole numbers are also called positive integers. Okay. 0 is also a whole number because whole numbers are real number that do not have fraction, decimal, and negative number. Please, you have to keep all these points in your mind because all these will help you in solving true, false, or fill in the blanks or match or column. Okay. 0 is also a whole number because whole numbers are real numbers that do not have fraction, decimal, and negative numbers. Clear? Number 11, every whole number is a factor of 0. In this word, every number which exists in this word is a factor of 0. Number 12, 0 is not a factor of any number, but as you know that 1 is a factor of every number, but 0 is not a factor of any number, but all the numbers are factors of 0. These 2 points are very much important. Clear? Okay. Number 13, 1 is neither prime or composite number. Why 1 is not a prime or composite? Because it has only 1 factor. And for prime number, it must have 2 factors, the 1 and the number itself. Similarly, composite number have at least 3 factors. That's why 1 is neither prime or composite number. Clear? Yes, I already told you that today I will tell you, but rather you have to learn the first 11 prime numbers. Okay. So here I have to written all the prime number. Please, you have to read silently at least 3 times in your heart. Clear? Because it is very much important that you have to read these prime number with understanding. Okay. So please read after me. 2. Why 2 is a prime number? Because it is divisible by 1 and 2. Is there any other number where 2 is divisible? No. It has only two factors, 1 and 2. So it is prime number. 3, 2, 3, 5, 7, 11, 13, 17, 19, 23. Look at 23. It is divisible by 1. It is divisible by 23. Any number, other number 23 can? No. So 23 is a prime number. 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. All these are prime number between 1 and 100. Later on, I will also tell you the test of divisibility. It will help you in finding the prime number which are greater than 100. Okay. Okay, can I move towards the next slide? Okay, I have to move. Okay, this one is point number 14. Now we move towards point number 15. To determine whether a number is prime or composite, check its divisibility by all the prime numbers before it. Okay, first of all, divisibility test by 2. What is the first test? It is if a longer number is given to you, okay, I have to write this number for you, so it becomes easier for you. How you have to test the test of divisibility? Look for 4, 5, 7, 3, 3, 3, 0. This is a number, okay, units 10, 100, 1,000, 10,000, 100,000, and million. Look at this number is 4,573,330. This number is 7-digit number is given to you, and you have to tell without dividing. Just seeing this number, can you tell is this divisible by 2? Yeah, it is divisible by 2, but because in its unit base it has 0. They are saying all numbers are divisible by 2 if in unit place they have 0 or 2. Okay, I have to change it here. If even it has 2, or even it has 4, or even it has 6 or 8. So all if any number is given to you and in the end, in the unit place, it has 0, 2, 4, 6 or 8. This means that the whole number is divisible by 2. But here, suppose I have to write another number. Look here, 6, 6, 6, 6. And in the end, 7 is given. Now, is this number divisible by 2? No, because at the unit place 7 is given. So this means it is not divisible by 2. Always remember in this word, all the number divisible by 2 are those numbers. In the unit place, they have 0, 2, 4, 6 or 8. Clear to all? Very good. Now we move towards the next point, test of divisibility. Point number 15 that I will tell you different test of divisibility. First, I will tell you test of divisibility related to 2, number 2. Clear? All the number in the unit place you have 0, 2, 4, 6, 8. All are divisible by 2. Now we move towards the next test. That is divisibility test by 3. Okay, I have to write a number for you, so it becomes easier. Look front. I have 1, 1, 1. According to this test, they are saying a number is divisible by 3 if and only if the sum of digit of these number are divisible by 3. Look at this one. I have to written 1 by 1. Now I have to take its sum. Okay, 1 plus 1 plus 1. So all these are equal to 3. So is this 3 is divisible by 3? Yeah. So this means this number 111 is also divisible by 3. Okay. So I have to check this for you. Look here. 1, 1, 1. I have to check. Look here. Okay, wait. So we have, look here, 3 9 times. As all we know, 3. What is 3 9 times? 3 9. 3 is a 9. So you have to write it here. Look here, 9. So rather you have to write 99. Okay, you have to write 33. Okay, the other you have to write, look here, look here. First we have to take these two. 3 3 is a 9. Okay, this one is 9. So when I have to subtract this, I have to subtract 11 from 9. What is my answer? Oh, just wait. 2. From here I have to put 1. So it becomes 21. So this means 3 7 times 21. So 1 and 11 is divisible on 37. 37 3 times 1 1 1. Clear ho gaya? So all the number is divisible by 3 if their sum is equal a number is divisible by 3 if and only if is the sum of digit is also divisible by 3. Tell me any other number. Look here, 7 7 6 5 3 2 1. Look, now I have to add this all these number. Look here, 7 plus 7, then 7 plus 7, what will be the answer? 14. Okay, 14 plus 6, what will be the answer? 14 plus 6, 20. Very good. Okay, 20 plus 5, what will be the answer? 25. 25 plus 3, 28. 28 plus 2, 30. And 30 plus 1, 31. So 31 is not divisible by 3 because 3 tens are 30 and 3 11s are 33. But instead of 1, if suppose here this one is written, this one is written. Now my answer equal to 33. Is 33 divisible by 3? Yes, it is divisible by 3. This will now this number is divisible by 3. Okay. So if any number is given to you, you have to sum up and then you will get your answer. Clear? Now we move towards the next divisibility test. According to this, all numbers are divisible by 5 if at the unit place it has 0 or 5. Any number is given to you. Look here, suppose. Okay, wait, just wait. I have to write it for you. Just, okay. 6, 6, 6, 6, 6. In the end, it has 0. This means it is divisible by 5. Or in the end, if 5 is given, this means it is divisible by 5. Okay. Now we come to the another divisibility test, which is very much interesting. Okay. That is a number that is divisible by 7. Look here, we come to this test, divisibility test. Okay, just wait. Okay, divisibility by test. The number between, okay, then difference between twice the unit digit of given number and the remaining part of given number should be multiple of 7 or it should be equal to 0. Okay, I will explain. If any bigger number is given to you, okay, any bigger number is given to you. First, but tell me any number. Okay, suppose 3, 4, 5, 6. This one is number, okay. Which number I have to return here? I have to write it here, beta. 3456. Okay. They are saying the difference between twice the unit digit. Okay, at the unit place, which digit is given to you? At the unit place, which digit is given to you? Please tell me at the unit place, which digit is given to you? Okay. Yes, at the unit place, which digit is given to you? I have written here 3, 4, 5, 6. At the unit place, which digit is given to you? 6. They are saying twice the unit. When I have to twice the unit, 6 will become, yes, 6 will become 12. Very good. Now, what shall I have to? First, the digit is 3456. At the unit place, which digit is given to me? I again write it for you. 6. When I have to twice 6. Twice 6 means I have to multiply this 6 with 2. Okay, I have to multiply this 6 with 2. Twice. What is the meaning of twice? Obviously, we have to double it. So when I have to double it, it becomes 12. Now, what is the original number which I gave to you? That is 3,456. This one is the original number. Please, beta, listen to me carefully. 3,456 is the original number. At the unit place, you have 6. Okay. What shall we have to do? We have to double this digit 6. When I have to double this digit 6, what will my answer? My answer is 12. Now I have to subtract this 12 with this 345. Okay. Please help me in subtracting this. Hurry up. Very much easier. Who will tell me when I have to subtract 345 minus 12? What will be my answer? Okay, my answer is 333. Now, look here. It is 333. Okay, again, look at its unit place. Which number is given at the unit place? 3 is given. Okay, again, you have to double this 3. When you have to double this 3, what will be your answer? 6. Now, what shall you do? You have to minus 6 from this 33. Okay? This one is clear? What shall you do? You have to minus 6 from 33. Okay? And what will be your answer? 27. So, is 27 visible by 7? No. So, this means this number 3,456 is not visible by 7. So, we have also check it. Look here. You have to check either this plus is okay. Now, again, I have to write the original number. So, it becomes easier for you to check. 3,456. Sorry. This one is the number. Now I have to divide it by 7. And when I have to divide this number by 7, okay. Look here. When I have to divide this number by 7, so my answer is in points. This means this number is not visible by 7. Okay. This one is clear to all of you. Now I have to take one other number. So it becomes easier for you to understand that if a longer number is given to you, how you came to know that which number is divisible by 7 or not, or it is not visible by 7. Now, look here. Now I have to take another number, that is 2,455. Okay. At the unit place, which number is given? 5. And when you have to double this 5, what will be your answer? 10. Now you have to subtract this 10 from this 245. When you have to subtract this 10 from 245, what will be your answer? Please tell me when you have to subtract. I'm talking to you. You have to double the unit place number, then you have to subtract it from this remaining part. So it is equal to 235. Okay. Again, look at the unit place. Which number is given to you in the unit place? 5. Okay. 5 is given to you. 5 is given to you. Now you have to double it. Hurry up. Okay. In the unit place, 5 is given. When you have to double it, 5, it becomes 10. Okay. Again, you have to subtract 10 from this 23. What will be your answer? Your answer is 13. Is 13 visible by this 7? No. So it is not divisible by 7. Okay. Now I have to take another number. Look here. Just give me 1 minute. Okay, I have to take one other number. Okay, suppose I have to take 259. At a unit place, which number is given? 9. I have to double 9. When I have to add 9 plus 9, what will be my answer? 18. Okay. So when I have to subtract 18 from 27, what will my answer? It is equal to 7. So tell me, is 259 divisible by 7? Yes, it is divisible by 7. Why it is divisible by 7? Because through the test of divisibility, we came to know that in the end, the number came which is divisible by 7. This means it is divisible by 7. Clear to all? Okay. Okay, I have to take one other example because I want that all the confusion, there must be no confusion at all to you. Okay. Now I have to take a bigger number. Suppose. Okay, yeah. Now I have to take a bigger number, that is 959. Okay. Now at the unit place 9 is given. When I have to double 9, what will my answer? My answer is 18. Okay. And now I have to subtract this 95 from 8. 18 from 95. So my answer is 77. Is 77 visible by 7? Yes. This means this number 959 is divisible by 7. Now I think so it is clear? Clear to all? Very good. Now we move towards the next test of divisibility. I think so. Divisibility test related to number 2, 3, 5, and 7 are clear to all of you? Very good. Nice. Now we come to the next divisibility test, that is related to a number which is divisible by 11. Okay. Now, they are saying the difference between the sum of digit at odd places and the sum of the digit at even place of the number is 0 or divisible by 11. Okay. Again, I have to take write an example so it will become easier for you. Okay, I have to take a bigger number. Suppose I have to take it here 5, 0, 2, 5, and 9. Okay. Now they are saying okay, you have to take the difference between the digits which are in the unit place and which are in the even number or in the odd number. Okay. First, we have to take the digit which are in the even numbers. Clear ho gaya? So that are, look here. First, we have to take the digit which are in the even number. Look here. Now, you know about even and odd numbers are which are not divisible by 2 and even number which are divisible by 2. Okay, look here. I have to show it to you. Look here. This is odd number, 9 is odd number, this 2 is odd number, this 5 is odd number. And this 0 and 5 are even number. Okay. So I have to write it here. Here, even number, the digit which are in the even places. Even place digits. Here. We are not taking even number, we just take the digit which are at the that are at even place. Okay. Just where I have to move the cursor. Why it is not moving? Okay, now it moves. So I have to take digits which are at even places. That is 0 plus 5. So when I have to add these two, I will get 5. Clear? Now I have to take the digits at the odd number, odd places, odd place digits. Okay, so I have to add all these. This is 5, yes, plus 2, yes, plus 9. Odd place are, look here, 1, 2, 3, 4, 5. It is 5-digit number. The 1, 3rd, and 5th digit number place are odd places, and 2 and 4 are the even places. Is it clear? So when I have to add all these, it is equal to 16. Okay. Now they are saying I have to subtract these two. The digit in the even places will be subtracted from the digit which are in the odd places. So when I subtract 16 minus 5, what is my answer? 11. So is 11 is divisible by 11? Obviously, yes. So this means this is divisible by this number 50,259 is divisible by 11. And similarly, if it is equal to 0, again, this one is divisible by 11. Clear to all? Okay, well done. Now we move towards the next test of divisibility. It is related to divisibility test by 13. Add 4 times of the last digit of remaining number and repeat the process until get a 2-digit number. If that 2-digit number is divisible by 13, then the given number is divisible by 13. Okay, I will take an example for this. So again, this it becomes easier for you to understand. Okay, is that number is divisible by 13 or it is not divisible by 13. Okay, I have to take up one bigger number, but before it, I have to erase all that which we have already written. So I have to make this screen clear. Okay, no, no, no. Oh, wait, wait, wait. Okay. Now we come to the divisibility test by 13. So I have to take a longer number, suppose 5, 9, 3. Which number I have to write? 7. Okay. And then 1. Okay. I have to take 59,371, a bigger number I have to take, and you have to check either this number is divisible by 13 or not. Very easy. At the unit place, which number is given, beta? At the unit place, which number is given? 1 is given. So what shall you do? You have to multiply this by 4. They are unit number, you have to multiply it by 4. Okay, when you have to multiply and then you have to subtract it from the remaining number. Okay, so the remaining number is, first I have to write the remaining number, that is 5937. And when I have to subtract it, multiply it by 4, the one which is at the unit place, I will get 4. So I have to subtract this 5937, 5937 minus 4, I will get 5,941. Okay. Sorry, they are saying I have to add. Sorry, I have to add. So here I have to add. So I have to add. So then I get 5,941. Okay. Again, this number, I have to take the number which is at the unit place. Which number is at the unit place? 594. Which number is at unit place? 1. Again, 1 is here. So I have to add again, multiply it by 4. And then I have to add in this number. So I will get, which number I have to get? I will get 598. Again, I have to take this number 598. Which number is at the unit place? Please tell me which number is at the unit place? 8 is. And when I have to multiply 8 with, and the remaining number is 59. Okay. When I have to multiply 8 with 4, what will be my answer, beta? Yes, my answer is, yes, 4 8s are 32. So I have to add this 32 with the remaining portion of the number, that is 59. So I will get 90. Yes, I will get 91. Is 91 divisible by 13? Yes, in 13 timetable, 13 sevens are 91. So this means this number 59,371 is divisible by 13. Again, look here. Any number given to you, you have to just concentrate on the last digit, that is unit place. And you have to multiply this unit place digit with 4 and then add this 4 with the remaining digit. Okay. Okay. So you will get your answer. You have to continue this process unless you will go 2-digit number. And then you have to check whether this 2-digit number is divisible by 13 or not. Clear to all? Okay. Now this means I have to move towards the next slide. Okay. I have to move. Just better give me few seconds. Okay. First I have to erase this. Then I have to move. Okay. Now we have to move towards the next slide. I think so. Divisibility tests are easier for you. All these are divisibility tests. First, we have to learn about which number is divisible by 2, 3, 5, 7. All these are prime numbers. Then we check the divisibility test. Which number are divisible by 11 and 13? Clear to all? Okay. Now we come to point number 16. According to this point, can product of two prime numbers be odd number, even number, or prime number, or all these three? This is your assignment. And in the next, when I have to upload my next video, then I will ask you about this. And you have to write the answer in the comments. Okay? You have to write the answer in the comments. So I came to know you have to understand or not. You tell me, can product of two prime number, you have to take any two prime number and then you have to multiply it and then tell me. Your answer is an odd number. Odd number means a number which is not divisible by 2, or an even number which are divisible by 2, or a prime number which has only 2 factors. Then you have to tell me the answer. Okay, this is your assignment and you have to write in comments. Okay, now we move towards 17. 1 is factor of every number. I already discussed you that 1 is the factor of every number. Next point, division test. Division by 0 is undefined. We know that when we have to divide any number with 0, we will not get any answer. So it is undefined. 0 is neither positive or negative. It is an absolute value. Okay. Next, factor cannot be fraction or decimal. It must be a whole number. Always remember, whenever you have to take the factor of any number, it must be a whole number. It is not a fraction or decimal. Clear? Next, 0 is multiple of every number. I already told you the 0 is multiple of, as you know that 1 is a factor of every number. Similarly, 0 is the multiple of every number. And when we have to divide any positive or negative number with 0, we will get undefined answer solution. Clear? Point number 22, prime number that differ by 2. This is very much important. Please better concentrate on this. Prime numbers that differ by 2, such as 5 and 7, are called twin primes. Such prime number what differ by 2. This is 5 and 7, but another is 13 and 11. When we have to subtract, we will get 2. Such prime number are called twin prime. In the comments, you also write more twin prime numbers. Clear? You know the first 100 prime number. You please tell me which are the twin primes. Clear? This is your assignment. Okay, now we move towards point number 23. 0 is multiple of every number. I already discussed it with you. Next, 1 is factor of every number as 1 divides every number exactly. 1 is why 1 is factor of every number because it divides any number exactly without any remainder. Okay. Next one is 37 and 73. When we have to reverse 37, we will get 73. And both are prime number. Such prime number are called reverse prime number. Okay. You will tell any other pair who is reverse prime number. Okay. Clear to all? 37 and 73 are reverse prime number. There are some more prime number which are reverse, such as, I will give you another example, 13 and 13, 1, 3. Okay, I have to write it for you. Look here, beta. 13. When I have to reverse, it becomes 31. So these are also reverse prime number. But there are so many other reverse prime numbers. There are so many. So you have to write in comment section what are the other prime number which are reverse prime number. And then also you tell me what are the number which are twin prime. And they are different by 2. Clear okay, beta? Now we move towards the next. It is very much important. If P and Q are whole number, okay? 2 variables are given to you. P and Q. If P and Q are whole numbers such that P multiplied by Q is equal to 13. So what is the value of P plus Q? When we have to multiply P with Q, we will get 13. As you know that 13 is a prime number. So what is the value of P? Obviously, it is equal to 1. So when you have to add 13 plus 1, what will be your answer? 14. Okay. Next, if P multiplied by Q is equal to 31, very easy, similar to that. Okay. If P multiplied by Q is equal to 31, find value of P plus Q. This means when we have to add both of these two, we will get 31. This means, and what is the value of P plus Q? Very easy. This means we have to multiply 31 with 1 because 31 is a prime number. It is divisible. It is it has only one factor, that is 1. So obviously we have, if I want to multiply P with Q, so 31 multiplied by, obviously when I have to multiply 31 with any other number, I will get any other answer. So obviously I have only one option left, that is 1. So this means I have to multiply 31 with 1. So I will get 31. 31, 1 times 31. So what is the answer? P plus Q. Yes. Very good. 31 plus 1 is equal to 32. So this is your answer. Clear? Now we move towards the next point number 28. If n is a whole number such that n bracket n plus 28 is a prime number, find prime number. Okay. Again, I will write the solution for you. It is very much easier. Okay. They are saying, start, okay. 2 are given, n and n plus 28. So I have to start the value of n with the first number, that is 1. Okay. So starting with n is equal to 1, we will get n plus 28. So what is the value of n? Obviously, it is equal to 1. So 28 plus 1, what will be my answer? 29. So 21 multiplied by 1 is equal to 29. That is a prime number. So thus the prime number is 29. Why it is 29? Because I have to take the first value, that is 1, and when I have to add, I will get a prime number. That all. Okay, I will read this all the solution which I have written for you. Look here, starting with n is equal to 1, we have n plus 28 is equal to this. Which answer I have to get? 29. This one is a prime number. Next, the prime number in this case is 29. To explain the answer, we need to understand that a prime number is a whole number that has positive divisor other than 1 and itself. Okay. So what is the divisor of 29? Obviously only 1. So 29, 1 times 29. So what is the value of n? 1 is 1. And what is the prime number which we get? That is 29. Clear? Okay. 29. It is very much important. The process of expressing number as a product of its prime factor is called prime factorization. What is prime factorization? The procedure for expressing any given number. Any number is given. Suppose 18 is given to you. Okay, I have to write it for you. Look here. Suppose if I have 18, what shall I do? I have to express this 18 by multiplying it by, okay, in which table 18 will come? Okay, 2 multiply by, okay, just give me 1 second. Just give me 1 second. I have to put the sign. Okay. Look here, yes. Okay. Look here, I have to write it for you. Look here. Suppose if 18 is given to you as, now tell me other than 1, in which table 18 will come? 2 multiply by, we can use bracket. 2 multiply by, yes, 9 is equal to 18. Oh, sorry. 2 multiplied by 9 is equal to 18. Now 2 is a prime number. Now tell me again, if 2 is a prime number, so we have to leave it this. Now, and 9 is the multiple of which two numbers? 3 into 3. Okay, 3 into 3. So all these 2, 3 into 3 are the prime factors. So this procedure, I have to first I have to multiply 18 with 2 into 9. Again, further I have to multiply this 9, 3 into 3. Now in the end result, I will get 2, 3 and 3. 2 is a prime number. Why 2 is a prime number? Because it has only 2 factor, 1 and itself. Similarly, 3 is a prime number because it has only 2 factor, 3 and 1. So this means 18 is the factors 2 into 3 into 3 are prime factors. So this procedure is called prime factorization. Clear? Now we move towards point number 30. That is, wait. Okay. Prime factorization and finally factorize two different things. Okay, please keep in mind. Prime factorization is a process in which in the end result we will get prime factors. But finding factors is another thing. Finding prime factors is another thing, and prime factorization procedure is another thing. Please, you must keep in mind this thing. Okay. Next, the fundamental theorem states that every whole number greater than 1 is either prime number or it can be expressed as the unique product of its prime factors. What the fundamental theorem states? It states that all the numbers which are greater than 1 are prime number or they are the product of prime factors. Okay. And this theorem is called fundamental theorem. All numbers which are greater than 1 are either prime number or they are the prime factors of product of the prime factors of that unique number. As we do it, suppose 18, it is not a prime number. But when we have to convert this into prime factors, we will get, in the end result, I will get prime factors. So this means all the numbers are either prime numbers or they are the product of prime factors. Clear? Similarly, they give you some other, today we learn about test of divisibility, we learn about prime number, composite number, prime factorization. Now we move towards the next topic, that is square, and then the square root, cube and cube root. They are saying, what is the square of 72? Obviously, what is the meaning of square? Multiply same number 2 times. So if 72 is given, this means We have to multiply 72, multiply by 72, we will get 5,184. Similarly, we have to take cube of 5 into 5 into 5. What will I will get? 125. Okay. Now they are saying this 0, 1, 4, 9, 16, 25, 36. Okay, look here. 0 into 0, 0. 1 into 1, 1. 2 2s are 4. 3 3s are 9. 6 6 are 36. So all these are perfect square. When we multiply same number 2 times, we will get perfect square. This means it completely divides the whole number. Okay. Similarly, 0, 1, 8, 27, 64 are example of cubes. Why? Because when we multiply a number 3 times, look here, I have to divide, do it for you. Look here, I will do it for you. So it becomes easier. Suppose I have to write it here 3 into 3 into 3. Now please tell me the answer. 3 3s are 9, 9 3s are 27. So this 27 is a cube of this number 3. Clear? So, and this all these numbers 0, 1, 8, 27, 64 example of cubes. Clear? Okay. Now we move towards the next slide. I think so all these are very much easier. You have to understand. Okay, find 3-digit numbers where sum of the cube of its digits is equal to itself. You will tell me the 3-digit number when you have to add, sum in when you have to add, you will get the digit itself. And that number is 153. And you have to take first cube of all these digits. First is 1. 1 into 1 into 1, you will get 1, 5, 5, 5. You will get 125. 3 into 3 into 3. Recently, we have done 27. When you have to add 1, 125, 27, you will get 153. So the 3-digit number, when you have to sum its cube, you will get the number itself. Clear? Firstly, we will learn about the fundamental theorem. What is a fundamental theorem? That all the number which are greater than 1 are prime number, or they are the product of prime factors. And now we come towards the next. That is theorem. Theorem means that all the people in this world prove it is true, and that cold batch conjecture. This means in the most of the cases it is true, but still it is not a theorem. Okay, so Goldbach's conjecture states that every even number greater than 2 can be expressed as the sum of 2 primes. Okay, it is expressed as the 2 primes. I think so. It is clear to all. Can I explain? Okay, I will explain it to you. Okay, they are saying every even number greater than 2. So I tell me any even number which is greater than 2, suppose that is 4. They are saying when you have to, you can express this sum of 2 primes. Okay, 4. I have to write it 4. So 4 is equal to, you have to sum it 2 plus 2. So it is equal to 4, or you can express in this way. Okay. Now we comes to the next, any other number, suppose 6. So you can express it here in this way. 3 plus 3. Okay. So these are the sum of 3. I have to write it here. 3 plus 3. Okay. Similarly, if 10 is given, you can express 5 plus 5. So it is equal to, these are 2 prime. Any even number. Even you can take any even number. In the most of the cases, they are the primes. Okay? Most of the cases, not all. This is a very important point you have to keep in mind. Okay? Now we move towards the next slide. I think so. All the points are clear. Am I right? Now we move towards the next. Oh, we have to move towards the next slide. That is 37. Okay. Now we 38. Okay. The process of expressing a composite number. Composite number means the number which have minimum 3 factor and the maximum has no limit. A product of its prime factor is known as prime factorization. Okay. And maximum are finite number of numbers. Okay. But maybe it may be 10 or 100 or 10,000. Okay. Next, the HCF stands for highest common factor. What do the HCF stands for? Highest common factor. HCF, okay, I have to erase all that so it becomes easier to understand what I am saying. Okay. Okay. The HCF stands for highest common factor. Next point, number 40. HCF of two or more number is the largest factor that is common to all the number. If you have two or more number, and how you have to find the HCF? Few, suppose I have to write it for you. Suppose here I have to take two numbers. Suppose I have to take 6 and 18. Okay. Now I have to take the factors of both of these two. Factors of 6. Please, you must understand factor mean number divisible by 6 without any remainder. So 1 is divisible, 2 is divisible without any remainder, 3 is divisible. Is 4 divisible? No, because we have 2 remainder. Is 5 divisible? No. In the end, you have to write 6. Now move towards the next. Factors of 18. So we will get 1 is divisible, 2 is divisible, 3 is divisible, 3 6 are 18, yes. 4 4s are 16, 4 5s are 20. Is 18 divisible? No. 5, no. 6, yes. And in the end, you have to write 18. Okay. Now, first you have to take common factors. Common factors. So what are the common factors? Yes, 1 is common, 2 is common, 3 is common, and 6 is common. Now we come to the highest common factor. Which is the highest common factor here? 6. So this is HCF. Now this point is clear? Very good. Now we move towards the next point, LCM. LCM stands for least common multiple, and LCM of two or more number is the smallest multiple that is common to all these two numbers. Okay, smallest. Here we have to take the smallest. Okay, I will give you an example. No problem. Just give me 1 second. I have to write this example for you. Okay. I have to take two numbers. And yes. Look here. Suppose I have to take 4 and okay, I have to take 9. No, I have to take multiples. Okay. Multiples of 4. First, I have to write it this. Tell me 4 times table. Hurry up. 4, 8, 12, 16. Yes. 20. Next. 24. Yes. Next. 28. Next. 32. Next. 36. Next. Yes. 40. Next. 44. 48. 52. Next. 56. Next. 60. 64. 68. And 72. I think so these are more than enough. Now we comes to multiples of 9. Okay, these are 9, 18, 27, 36. Yes. 30, 9 fours are 9 fives are 45, 54, 63. Yes. 72. Now tell me the common multiples. So common multiples are, yes, tell me who are common. Yes, very easy. 36 and 72. So which one is smallest, beta? So you have to write least common multiple, that is 36. So 36 is your LCM. Clear, beta? Now we move towards the next slide without delaying. Okay. Okay, this one is the last slide for today. That is, okay, wait. These are very much important slide, beta. For Moodle, because if bigger number is given to you, then you don't take its factor, or you bigger numbers are given to you, don't take its multiples. Then you have to use the table method, okay? And for table method, you must use the formula. Formula for finding HCF is equal to common factor, and formula for finding LCM is equal to common multiple multiplied by uncommon multiple. Suppose I have to write this also for you. Look here. Look here. If two bigger number is given to you, look here. Suppose 54 is given to you and 72 is given to you, and you have to find its. Yes, you have to find its. What you have to find its? You have to find its HCF and LCM both. So first of all, you have to take. Always remember, you have to divide it by prime factors. What is the prime factor? First prime factor, you have to use x. Wait. I have to draw a line so it becomes easier for you to understand what I'm teaching. Okay. Is it clear? So first I have to put our lines and then we have to solve. 54 and 72. Okay. Okay. Here I have to write 2. In 2 times table, when 54 will come? Very easy. Okay. And in 2 time table, when 72 will come? 36 times. Clear ho gaya? Again, it is not divisible by 2 because 2 is common only in 36, but we will not come in 27. But one, okay, we have to keep in mind the test of divisibility. In the end, you have 7, so it is not divisible by 2. So which another prime factor you have to use? 3. Always remember that here we are the players which are prime factors. Okay. Just when we have to play cricket, we are bowlers, we are batter. We can't send batter to bowl. Okay. Similarly, so this means here you have to only write the prime factors, not the any other factors. Okay. So it is not divisible by 2. Next, 7 plus 2, 9. 3 plus 6, 9. So it is divisible by 3. Yes, obviously it is divisible by 3. So I have to divide it by 3. So in 3 times table, when 27 will come, I have to write it for you. Wait. So it will come. 1 minute. When it will come. Oh, sorry. It will come 9, and then it will 3 nines are 27. Very good. And then 3 12s. Okay. Again, it is divisible by 3. So I have to write it for you, beta. Okay. So I have to write it for you 3. So when I have to divide it by 3, I will get. Again, I have to get 3. 3 3s are 9, and then I have to get 3 4s are 12. Now, in HCF, I have to only write the common factors. Okay, HCF, I have to take only the common. Which one is common here? 2 into 3 into 3. 2 3 3 3s are 9, 9 2s are 18. So 18 is your HCF. And how you have to find LCM? LCM. Okay, you will first you have to write this formula. It is CM multiplied by UCM. Okay, uncommon multiple multiplied by common multiple. So we have to write it here. Common are the same. 2 into 3 into 3, and uncommon are 2 are uncommon 3 into 4. Okay, I also write the formula for HCF also. So okay, first I have to solve this for you. Okay, you have to multiply all these 2 into 3 into 3 into 3 into 4. Hurry up. Quickly. Look here, 2 multiplied by 3, multiplied by 3, multiplied by 3, multiplied by 4. So you will get 216. So this one is its LCM. Now I have to write the formula for HCF also. HCF is equal to CF. Okay. So I have to write it. This method is called for the number which are longer. Okay. This is called table method. Clear to all? So formula for finding HCF is CF, and formula for finding LCM is CM multiplied by UCM. Common multiple multiplied by uncommon multiple. Now becomes the rule of multiplication and division. Plus into plus is equal to plus, positive into negative, negative, negative into positive, negative, and negative into negative, positive. In other words, if same positive into positive, negative into negative, if same are given, then your answer is positive, and different are given, your answer is in negative. This is all for today. I think so. You have to understand all that. Okay, wishing you best of luck. Wait for the next video which I have to upload it soon. Allah Hafiz.